So, hello everybody, and welcome to the video lectures on Octave with Spice. And we start chapter 2 in this lecture, GNU Octave as calculator. So, GNU Octave is actually a very convenient calculator. So, whenever I have to calculate something, I will not use Excel or anything like that. I will actually use GNU Octave. Well, of course, I'm used to it, but it's actually very convenient, and we will soon see that why. So it can be used as a simple calculator with the additional spice, if you like, that it can handle variables, which is nice. But it's, as I mentioned in the introduction lecture, the true power of GNU Octave comes from the fact that it handles matrices and vectors very nicely. But before going to the matrices and vectors, let us start with simple calculations and variables. So basic arithmetics in GNU Octave is pretty similar to any computing language. I mean, similar to Excel also, I think. So plus and minus signs, yeah, they are what they are, obviously. So the multiplication sign is star, and it has to be given always the star. We cannot write AB like A times B, as sometimes in mathematical formula. Star has to be used always for multiplication. Or the division sign, this is the slash, this kind of slash, and then exponentiation, so raising to a power, is this hat. We will not be using that too much. Okay, then there are precedences. So precedences mean that if you remember from the school, so first you calculate multiplication and division, and then addition and subtraction, and go from left to right. And these are called precedences or precedence rules, and well, they are more or less the natural rule what you learned in school that are used here in Octave also. The problem is, of course, that these rules, depending on which decade and which country you went to school, there are actually differences to these rules. They are not completely the same everywhere. So there is no mathematical emperor of the world who says that what are the precedences really. So how do we know that which way to calculate them? So of course the answer is parentheses. So they are strongly encouraged. So I encourage to use parentheses. It's never wrong to put extra parentheses there. So do that if you don't know how to calculate. And here is the 2.1 example illustrating this point. So what is precedence? So suppose we want to calculate the following. So formula 2.2. You might notice that I used this single running numbering here. So it's maybe not something that you used to, but then if I refer to some formula 2.2 or example 2.1, then you know, you can guess pretty easily where they are in the notes. Okay. In any case, so we have an equation, or actually calculation 2.2. We want to calculate 1.4 times 10 to the power minus 2 plus 2 divided by 7 plus 3. So what is this? So let us start calculating by hand, so that this is maybe the only time we calculate anything by hand in this course. But let's see what it is. So the first one here is, of course, 10 to the power minus 2 is 1 over 100. So this is 1.4 over 100 is the first thing here. The second one is 2 divided by 7 plus 3, so that's 2 divided by 10. So this is, of course, what it is. And then I can multiply this by 10, the upstairs and downstairs, so this is 20 over 100. So then we have 100 downstairs on both of these, so this is 1.4 plus 2 over 20 over 100, something like this. And this is easy to calculate, so let's, as a decimal, it's 0.215. 4. Okay, that's kind of obvious, and those calculations are not the point. The point is, let's see what would Octave say about this. So we open Octave here, or you open it clicking the corresponding icon on your system, and again you have something like that. So I have a previous session here open already, so let me type Ctrl L to clear the screen, and let's see, let's try simply imitate this. How would we put this? So 1.4 is probably 1.4, that's it. Then we have okay, so this is apparently a multiplication sign in Anglo-American system. In the Finnish system I think it's just dot. In any case, with Octave, that's the star, so let's have a star there, and then we have 10 to the power minus 2, so 10 is like this, power is the hat, and since at least in my keyboard the hat is kind of combined character, so if I want to put hat and then press O, you get hat O, so you have to type the hat key and press space in my system, but this is probably known to you. So that's, I get the hat there, or circumflex if you like. And what was that? That's the power minus 2, so let's have a minus 2 there. Okay. What then? Then we have plus something, let's put spaces there also, let's put a lot of spaces. 2 divided by 7 plus 3, so 2 is 2, then divided, so this was the division sign, and then was 7 plus 3. Okay, so something like this should correspond to this. And let's just type enter, and we get something like 3.2997. This is not the same as here. So what was the problem here? And the problem here is that is actually, I press arrow up, it's this here is the problem. So Octave, I put the spaces there, so it's always a good idea to put spaces so it's easier to read for the human reader, but unfortunately Octave does not care about these extra spaces at all. So this here is the same as this. Let's try. Yeah, it's the same. And now you see already why this is different. So the 7 plus 3 has to be in the downstairs, so to say, of this division. So how do we put them there? Well, the obvious answer is, let's put parentheses there. Sorry about this. And let's see what happens now. And now it says it's 0.214, which is the correct answer. So this was just to explain to you that you should use parentheses. Then there is a minor point here. Also there is this 10 to the power minus 2, so this minus 2 as a whole should be in the power. So I strongly recommend to put there parentheses also. But apparently in this case it was not needed. And then whether there are spaces around these stars or not, it doesn't matter. So like this, it's correct. So this was the whole point of this example, was just to really illustrate that the parentheses are something that you should use if you are not completely sure about the precedence. And also, if you are not completely sure about the precedence, if you don't know which way they go, well, just try. Okay, then there is an exercise for you, and just again I remind you of this funny way of numbering. So this is now exercise 2.3. So there are no exercises 2.1 or 2.2 because 2.1 numbering refers to this example, 2.2 refers to this calculation, or Okay, so the first exercise in chapter 2 is exercise 2.3, and this is viral precedence problem or viral math problem. You can Google this and see a lot of arguments what this should be. So you have to calculate the following with GNU Octave. So 8, and apparently this kind of funny sign is a division sign in I don't know, British and American systems. In Finland we certainly don't use a symbol like this, as far as I know. So 8 divided by 2, and then parenthesis 2 plus 2. So this is exercise for you. So you have to just calculate this. So somehow this is related to this example 2.1. Also there is the following exercise 2.4 for you about rounding errors. So this is again a word of caution. So computers are fast and getting faster and faster all the time, but they still make errors. So as humans, computers also do errors. Well, not as humans, they do errors in a usually in a different way, but nevertheless they do it. And one typical source of errors are rounding errors, as for humans also. And the way for this, there are technical reasons why computers do make rounding errors. Let's not go there. Let's just take this as a granted. And this exercise is that you will have to make Octave give you a wrong, or there's a typo, answer to you. And okay, you can maybe figure a different way also, but I assume that or the idea here is that you will make it give a wrong answer to you do rounding errors. And how do you enforce or actually trick Octave to make a rounding error? You have to give it nasty numbers in a sense that they are prone to rounding errors. And here's a hint for that. And well, how should I put it? You probably remember that due to your previous experience that 1/3, 1/3, is nasty for humans in the decimal system. I mean, 1/3 something, so it's not 33%, it's 33.3333333 and so on, at now some percents, and that's kind of difficult for us humans in the decimal system. So this gives usually rounding errors very easily. Okay, the similar thing is true for computers also, but actually 1/3 is not that nasty for computers. It's not nice either. And the reason is that computers don't use decimal system, but actually binary system. And it happens that 0.2, which is very nice in the base 10, so our decimal system, is actually relatively nasty, or actually pretty nasty in the binary system. So this is just a hint, and once you play around with equations involving 0.2, sum them up and subtract them and multiply or whatever you do, it actually turns out that it's not even a very complicated formula that will yield rounding errors with Octave. Alright, so now we have considered chapter 2, GNU Octave as a calculator, and looked at simple calculations. So basically we have just looked at calculated some simple formulas and looked at the precedence. So something to remember here is that use those parentheses whenever it is not completely clear what is the precedence. And this was the first video lecture on chapter 2, and in the next video lecture it's the same story, but now we add variables to the story. See you in the next video. Bye bye.